Good morning, students. I am Santan, working as a physics faculty in Target English Medium School. Today, in this part video, I would like to explain about what are the distinguish or differences between distance and displacement, and further we discuss the what is the speed and how many types of speed with suitable examples or explanation. Okay, now let me come to our point. Okay, so what are the major differences or distinguish between the distance and the displacement? It is one of the important question for either 2 marks or 4 marks in 9th standard level based in the chapter of motion. The first one is simply you can write the definition of distance and displacement under their respective category. So the actual length of the path traveled or covered by a body is called distance. This side under the displacement. The shortest distance between initial and final position of a body is called displacement. And the second one is distance is a scalar. Displacement is a vector. Already in the previous video I am clearly explaining that. Okay, in case of distance we don't consider any direction. Just whatever the path maybe it will be follow. Just what is the total length of the path, that is only we are considered. But in case of displacement, it is a vector. Vector means it must be have the direction along with magnitude. So already this one also I am clearly explaining that displacement is nothing but the shortest distance. The shortest distance or the shortest term is represented in one particular direction. That's why distance is always a scalar, displacement is a vector. And the third point is the magnitude of distance equal or greater than the displacement. Listen very carefully. The magnitude is nothing but numerical value. Okay, already I am explaining that in the previous video. Once you can check is it correct or not. The magnitude or numerical value of distance is equal or greater than the displacement. Now here under the displacement, the magnitude is nothing but numerical value is equal or less than the distance. Here small difference means the magnitude of the distance is equal or greater than or more than which one? Displacement. Okay, next one here under the displacement, the magnitude of displacement is equal or lesser than which one? Distance. Next under the distance. So we don't consider any unique path, means we can't consider any unique path. Whatever the path the body will be travel, that path only we are considered. But under the displacement we consider the unique path. Unique path means only one path. Here listen very carefully. We can't consider the unique path. Which one? In the distance we consider the unique path. Unique path means only one particular path. That is the meaning of that. And the fifth one, under the distance, the magnitude of the distance is always positive. It is not zero or negative. Under this one, the magnitude of the displacement is maybe zero or positive or negative. That is depend on the direction. Listen very carefully. Totally the major differentiations are distinguished between the distance and displacements are 5 are there. First one is we can write the definition on the both sides. The actual length of the path traveled by a body is called distance. The shortest distance between initial and final position of a body is called displacement. Distance is a scalar. Displacement is a vector. Next, the magnitude or numerical value of distance is equal or greater than the displacement. The magnitude or numerical value of displacement is equal or less than the distance. It cannot be follow any unique path, it will be follow a unique path. The magnitude of distance is always positive but not zero or negative. It is maybe positive or negative and zero, okay, based on the direction. When the displacement magnitude is zero, already I said that when a body is moving in a circular path, I said that where the body is started after completion of one rotation again come to the same point. But here distance is there but the displacement is zero because of the initial point and final point both are same. That's why there is no shortcut or there is no displacement. Next come to the what is the speed? So we can define the speed in the two ways. The first thing is the rate of change of motion. The rate of change of motion is called speed. The rate of change of motion is called speed. Another example is there. Okay, the distance covered by a body in a unit time is also called speed. Listen very carefully. The distance covered by a body per unit time is also called speed. Okay, but simply you can write that the rate of change of motion is called speed. Okay, so speed means we can represent it by the symbol of S or in certain textbooks we are also observing the V also. Okay, S or V is equals to so the rate of change of motion or distance traveled by the time simply. Okay. Distance traveled by the body. The rate of change of motion means motion is changes means is nothing but what is the meaning of motion? Already I said that clearly. The position of your body is changes with respect to the time and surrounding. Then you can say that the body is in the motion. If your body is in the motion, what we know that the distance of the body is gradually changes. Okay, or continuously changes. That's why distance traveled by the body upon time taken to cover that much distance. That's why speed is equals to distance traveled by the body upon time taken. Now here we are observing that how we can write simply means S is equals to d by t also. This is the simple formula. Instead of the words we can write it in the letters. S is equals to d by t. S is nothing but speed. D is the distance. T is the time taken. Now, according to the formula of speed, what are the units of the speed? So now, before going to that, speed is a scalar. Listen very carefully. The rate of change of motion is called speed. Speed is represented by the symbol of either S or V. So that is equals to distance traveled by the body upon time taken. Distance is nothing but d, time is nothing but t in the symbol. That's why speed is equals to distance by time. speed is a scalar quantity. Why? Or how we can say speed is a scalar quantity means simple here in the formula we are observing that distance is a scalar, time is a scalar. Okay, the ratio of the two scalar is nothing but a scalar. Because of in case of speed we consider the distance and the time. These two are the scalars only. Are understanding? Okay, that's why speed is also scalar. Means just we generally during the explaining or telling of speed. Okay, what is the speed of a vehicle? Like that one. Simply says that the speed of the train or the speed of the bus or the speed of the car is 60 kilometers per hour. Okay, means in this one we don't mention or represented the any direction. That's why speed is nothing but it is a scalar only. Okay, what are the units? Okay, it is a scalar quantity. Next, SI unit is, what is the SI unit? Distance is measured in meter, time is measured in second. That's why meter second power minus 1. Okay, and what is the CGS unit? CGS unit is centimeter per second or centimeter second power minus 1. Listen, the standard, the system according to the system of international, distance is measured in meters, time is always measured in any type of system, that is in the seconds. Okay, so in case of CGS unit, distance is in centimeters, time is in the seconds. Okay, but generally you are observing in our daily day-to-day life, to measure or to express the distance between the two towns or two villages or two places, we always use the kilometers but not in the meters. Okay, that's why based on that position we can express the speed of the speed of a body in another terms. What is that one means? Meter per second is the smallest unit to measure the speed of any vehicles. That's why the speed of the vehicles we represented in another units, that is the major units, that is the kilometer per hour. That's why simply we can write other unit of speed. What is the other units of speed? Simply kilometer per hour is nothing but kilometer per hour. This is the meaning of that one. So what is the SI unit? Meter per second. What is the CGS unit? Centimeter per second. But when you are in case of any vehicles, that is either two-wheeler or four-wheelers, whatever that vehicle. So in that vehicle, we can measure the speed, how much speed the body will be traveled. That is always we are expressed not in the meters per second. We are expressed in another term or another unit, that is the kilometer per hour. Now in this time I would like to explain. Now I will prove 1 kilometer per hour is equals to how many meters per second. It is very important. Means the conversion of kilometer per hour into meters per second or meter per second into kilometer per hour. It is a very important. Based on this one only, some numericals you can solve even in the regular, in the IIT oriented board also. That's why it is very important. First thing is conversion of kilometer per hour is equals to dash meters per second. This is our conversion of kilometer per hour, or simply into, we can write into meters per second. Now let me come to the point. 1 kilometer per 1 hour means kilometer per hour means you can write no one numerical value means 1. That's why 1 kilometer per 1 hour is equals to, it is other unit. This is converted which one? Meters per second. Now 1 kilometer is equals to how many meters? 1000 meters. That's why 1000 meters. Listen, 1 kilometer is equals to 1000 meters upon 1 hour is equals to, okay, here which one is there? Seconds. That's why how many seconds? 1 hour is equals to 3600 seconds. Okay, how we can say that? We know that 1 hour is equals to 60 minutes. That is, you know that 1 hour is equals to 60 minutes. Okay, into 1 minute, 60 into, in the place of 1 minute, how many seconds? 60 seconds. Because of our, okay, unit is meter per second. Time value we can consider in the second, not in the minutes. That's why 1 hour is equals to 60 minutes. 60 into 1 minute. That is the meaning. Now 1 hour is equals to 60 into 1 minute is nothing but 60 seconds. 60 into 60, 3600 seconds. That's why 1 hour is equals to how many seconds? 3600 seconds. Okay, let me come to that point. So 1000 meters by 3600. 2 zeros here, 2 zeros get big cancel. What is the remaining one? 10 here in the numerator side. In the denominator 36 is there. 2 5 ja, 2 1 ja, 2 8 ja. That's why 2 18 ja 36, 2 5 ja 10. That's why what you can write? 1 kilometer per, okay, hour is equals to, okay, 5 by 18 meter per second. So this is the relation, isn't it? Okay, 1 kilometer per hour is equals to, okay, 5 by 18 meters per second. That is the conversion of kilometer per hour into meter per second. Kilometer per hour, we should be also simply write kilometer per hour. Okay, like this one also we can write kilometer per hour also. So all of you listen once again. 1 kilometer per 1 hour is equals to how many meters per second? 1 kilometer is equals to 1000 meters. 1 hour is equals to 3600 seconds. 2 zeros get cancelled on the numerator and denominator side. The remaining terms are here 10. In this here 36 is there. So now with the 2 table, 2 5 ja is 10, 2 18 ja is 36. That's why 1 kilometer per hour is equals to 5 by 18 meters per second. Next one, same concept, conversion of here meter per second into kilometer per hour. Okay, so initially we discussed kilometer per hour into meters per second. Now meter per second into kilometer per hour. 1 meter per 1 second, that is one. That is equals to 1 meter is equals to how many kilometers? 1 by 1000, because of 1 kilometer equals to 1000. Okay, that's why 1 by 1000 meters, sorry, kilometers by 1 second is equals to how many hours? Okay, so that's why 1 second is equals to how many hours? 1 by 3600 hour. Okay, means 1 second is nothing but in the 1 hour 3600 parts. That is meaning of that. Okay, so I will tell simple method also after this one. Just we can come to that point. Now here this value bring to the numerator side. Then what we can write here? 1 meter per second is equals to, okay, so 1 by 1000 into, okay, 3600 by 1 kilometer per hour. Okay, two zeros get cancelled. 2 1 jar, 2 8 jar, 2 5 jar. That's right. 1 meter per second is equals to 18 by 5 kilometer per hour. So previously 1 kilometer per hour is equals to 5 by 18 meters per second. Now 1 meter per second is equals to 18 by 5 kilometer per hour. But how we can write simply means one thing is there. 1 kilometer per hour. This value we have the idea is there. What is the value? 5 by 18 meters per second. Then from this one simply we can write that, okay, 5 by 18 transfer to this side, it becomes to reverse, okay, reciprocal. That's why 18 by 5 kilometers per hour is equals to 1 meter per second. Means this value of transfer to this side, here no value is there, that's why it means nothing but 1. You getting this one or not? That's why 1 kilometer per hour is equals to 5 by 18 meters per second. This 5 by 18 from the left hand side is a transfer to the right hand side. Sorry, right hand side to left hand side. Then automatically this value is becomes to the reciprocal. Means in what? In 18 by 5 kilometer per hour is equals to 1 meter per second. The relations are very important for solving the numericals, mostly based on, okay, speed concept. Now we discuss the one simple example, okay, numerical about this concept. Numerical. Simple, okay. A car moving with 72 kilometers per hour. What is its speed in meters per second? Listen very carefully. So in this numerical or problem, they are given very clearly. What is the speed, initial speed of the car? 72 kilometers per hour. Okay, when a car is moving with this much of speed, this value we can express it or convert into the meters per second. That's why here what we can do here. So what is the value they are given? 72 kilometers per hour. kmph, kilometer per hour, is equals to 72. We can write like the same way. 72 into, here generally in normal cases this is, we can write like this one. 72 into 1 kilometer per hour. Understanding of 72 into 1 kilometer per hour, 72 kilometer per hour. That's why, so 72 we can write 1 kilometer per hour is equals to how many meters per second? Already note that 5 by 18 meters per second. 72 is same in the place of kilometer per hour. 1 kilometer per hour is equals to 5 by 18 meters per second. With 18 table. So that's why 18 4 ja 72. Then what you can write? 18 4. 4 into 5 20. That's why 20 meter per second. Simple thing. That's why a car moving with 72 kilometer per hour, what is its speed in the meters per second? Means 20 meters per second. Means in 1 second the car will be covered how much distance? 20 meter distance. That is the way of method to convert it from other unit to means kilometer per hour to meters per second. Next one is another numerical. A train moving with (95 meters per second). Just for understanding of it, but that much of speed is not possible. Okay. So simply I can say that 50 meters per second. Listen very carefully. A train moving with 50 meters per second. What is its speed in kilometer per hour? Listen very carefully. Okay. So a train moving with 50 meters per second. What is its speed in kilometers per hour? What is the value they are given? 50 into 50 meters per second is equals to 50 into 1 meter per second is equals to how many kilometers? 18 by 5 kilometer per hour. That's right. 5 then 10 into 18 180 kilometers per hour. That's right. A train is moving with 50 meters per second. Means in the kilometer per hour, what is its speed? 180 kilometers per hour. This is the way of method to solve the numerical when during the conversion of meter per second to kilometer per hour, or in the previous numerical kilometer per hour to meters per second. This is the way of method to solve the numerical based on this type of numericals or problems in this chapter.